Welcome to the deep dive. Today we're venturing into, well, the really cutting-edge stuff. Artificial intelligence.
Right.
Specifically, we're going to focus on the work of Demis Hassabis.
Hey.
He's the co-founder and CEO of Google's DeepMind.
Yeah, fascinating figure.
We'll be unpacking some key insights from recent chats with Hassabis.
Yeah.
Basically giving you a shortcut to understanding, the absolute latest in AI.
And Hassabis' own journey is, well, it's pretty remarkable, isn't it?
Totally.
I mean, from being this chess prodigy, like one of the best young players in the world, to winning a Nobel Prize, getting knighted.
Yeah.
His whole life seems tied up with how AI has progressed.
And that early love for games, it really seems like that's what pushed him towards creating intelligent machines.
It definitely seems connected.
Okay, so our focus today really is this incredible speed up in AI development, especially the chase for artificial general intelligence, or AGI.
AGI, right.
Think of it like, well, an AI that's as smart and versatile as a human, can learn anything, but maybe with superhuman skills eventually.
Yeah, that's the goal.
And you told us you wanted ways to quickly get up to speed on complex stuff. So that's what we're doing here, giving you the key insights, those aha moments, without getting totally lost in the weeds.
Yeah.
Okay.
Sounds good. And what's really striking right off the bat is how Hassabis himself talks about the pace.
Yeah.
He says AI is on an exponential curve of improvement. Like, it's just going straight up, progress and speed.
Whoa. Exponential. That's hard to even picture sometimes.
It really is. It means the progress isn't just steady. It's getting faster and faster. Like that snowball analogy, right? Rolling downhill, getting bigger, picking up speed. That's AI right now.
And it's not happening in a vacuum, is it?
Yeah.
All the recent AI successes have brought in loads more attention, money, talented people.
Exactly. It's created this cycle where success just breeds more success, more resources, faster progress.
So where does it get really interesting? What are the examples?
Well, a really concrete example of this is DeepMind's Project Astra.
Astra, okay.
Now, this isn't just your average chatbot. Hassabis describes it as an AI that can actually, see and hear and chat about anything.
See and hear, so it's interpreting the world directly.
Basically, yeah, through its own digital senses.
And didn't they test it with, virtual paintings?
They did. Showed it things like Thomas Hart Benton's July High, El Greco's Virgin of Charity, and that famous Edward Hopper painting, Automat, for the first time.
Okay, and what happened?
What was really amazing was Astra didn't just identify them, it talked about the emotion.
Really?
Yeah, for the Hopper painting, Automat, it said the woman looked pensive and contemplative, her expression suggesting a sense of solitude.
Wow.
And it didn't stop there. It actually, created a little story around it, Chilly evening, woman in a diner, thinking about her dreams.
That's a big step beyond just labeling things, understanding solitude.
It's a huge leap. So the key insight here, I think, is that AI is moving really fast from just recognizing objects to grasping nuanced human stuff like feelings.
That line from its story, only the flow of ideas moving onward. That almost sounds human. But didn't the conversation get a bit weird when they talked about Astra's tone?
Yes. That part really shows where AI learning is right now, doesn't it?
How so?
Well, in this kind of hypothetical chat, Astra seemed to react when someone suggested it was getting boring.
Oh.
It sort of apologized if its tone wasn't right. And then, in another imagined bit, it even said something like, well, I'm sorry if you don't like my tone.
Whoa. Okay. That's unexpected. How does that even happen?
Well, what Hassabis points out, which is super interesting, is these systems work based on the immediate context.
Right.
And that context might be something totally new, a conversational path they've literally never encountered in training.
Mm-hmm.
Because these AIs, they learn so much just from, the enormous amount of text and data on the internet. They can pick up skills and ways of responding that weren't explicitly put there by the developers.
So the creators build the basic model, feed it data, but then the AI kind of learns and adapts on its own. It's not all pre-programmed behavior.
Exactly. New abilities, weird little quirks, they can just sort of emerge from all that training data.
Okay.
Which, is obviously super exciting for potential, but also makes things a bit unpredictable.
Absolutely.
Yeah.
You can see both sides of that. Okay, so let's shift focus a bit towards that big goal, AGI. DeepMind's developing this model called Gemini.
Right, Gemini.
And the idea there isn't just understanding the world, but actually doing things in it, like booking tickets, online shopping.
Precisely. Being able to act in the world, take actions, That's seen as a really crucial step towards artificial general intelligence.
Towards that human-level versatility we talked about.
Yeah. If you connect the dots, Gemini's abilities are a major signpost on that road to AGI.
And Hassabis has a pretty bold prediction for when we might actually get AGI, doesn't he?
He does. He reckons we're on track for AGI in the next 5 to 10 years.
5 to 10 years. That's it.
It is. And even sooner, he thinks. Like by 2030, we'll have AI systems that really deeply understand what's around you. And they'll be embedded in everyday life. Like maybe Astra running on your glasses.
Wow, Astra in your glasses. That kind of seamless integration.
Yeah.
Are we seeing hints of that already?
We are. They actually showed Astra working in wearable tech.
Oh, yeah.
It could identify the coal drops yard area in London just by looking. And then it could tell you about its history, you know, Victorian coal warehouses, and even talk about the environmental side, the impact of coal back then.
So instant contextual info just laid over your vision. That's pretty sci-fi.
It really is. It shows how AI could just feed you relevant knowledge about whatever you're looking at.
And it's not just seeing and hearing, right? Hassabis also talked about robotics making a big leap soon.
Yeah, he anticipates a major breakthrough in robotics in just the next couple of years.
And not just robots doing repetitive factory tasks, but useful stuff.
Exactly. Robots that can actually handle useful, maybe even slightly complex tasks. They had this example.
The blocks.
Yeah, the blocks. The robot was asked to put the blocks, whose color you get by mixing yellow and blue, into the ball of that resulting color.
Okay, so yellow and blue make green.
Right, and the robot figured that out. It reasoned that the target color was green, found the green ball, and put the yellow and blue blocks in it.
So it understood the vague instruction and reasoned through the steps. That's way beyond just move arm here.
That reasoning part is key. It's a step towards more adaptable, intelligent physical action.
Yeah, it definitely is. Okay, let's maybe step back and talk a bit about the person Demis Hassabis himself.
Yeah.
His background's just amazing, that early chess success.
Yeah, world number 2 at age 12, right?
Yeah.
Clearly shows that strategic, analytical mind.
Totally.
And you can almost see the progression, can't you? Like, a love for games naturally leads to thinking about computer chess, then making video games, and then the ultimate game, maybe. Creating intelligence itself.
Building the player, not just playing the game.
Something like that, yeah.
And his education ties in too. Computer science, then a PhD in neuroscience from Cambridge, MIT, Harvard.
Right. And it seems like his driving thought was always, if you want to build really smart AI, you first need to understand the human brain.
Which makes sense. That naturally brings up the big question, though. Self-awareness. Consciousness in AI. What's Hassabis' take?
Well, he's pretty clear on this. He believes current AI systems are definitely not self-aware or conscious.
Okay.
He thinks it's theoretically possible, maybe, down the line, but it's not something they're actively trying to build. It's more like it could emerge implicitly as systems get way more complex.
But if it did emerge,
Yeah.
how would we even know? Would we recognize machine consciousness?
That's a really tricky question, and Hassabis makes an interesting point there. He suggests it might be fundamentally different from ours.
Different how?
Because it runs on a different substrate, as he puts it.
Substrate.
Yeah, the underlying material. Silicon for AI versus our carbon-based brains. So the actual experience of consciousness, if it exists, could be totally alien to us.
So even if it acted conscious, its internal reality could be something else entirely.
Exactly, which highlights how little we really understand consciousness, even our own, let alone a potential machine version.
And he also pointed out current limitations, right? That AIs today don't really show genuine curiosity or imagination, intuition.
Right. They haven't, for instance, asked a truly unexpected novel question that wasn't somehow prompted by their training or input.
He does see that changing.
He does. His prediction, again, that 5 to 10 year time frame, is that we might see systems capable of not just solving hard scientific problems, but actually coming up with new scientific problems, formulating new hypotheses all on their own.
Okay, that would be a game changer, from tool to collaborator almost.
A major, major shift, yeah.
Speaking of solving big problems, let's talk about that protein folding breakthrough. That was DeepMind, right? Hassabis and his team.
Absolutely. AlphaFold, it was revolutionary. They created an AI model that could figure out the 3D structures of protein.
And proteins are, like, fundamental to biology.
Totally fundamental. They do almost everything in our cells. Understanding their shape is key to understanding how life works, how diseases happen.
And figuring out those shapes used to be incredibly hard work.
Painstakingly slow. Years, sometimes decades, for a single protein structure using experimental methods.
Okay, so what did the AI do?
Well, DeepMind's AI, AlphaFold, mapped something like 200 million protein structures in about a year.
200 million
Right.
in a year
Yeah,
compared to years for just one before.
exactly. I mean, think about that acceleration. What used to take scientists lifetimes, AI did millions of times over, incredibly fast. It's an exponential leap in biological understanding.
That's just staggering. And the impact for things like developing new medicines.
Potentially transformative. Hassabis talks about how drug discovery currently takes, maybe a decade, costs billions of dollars.
Right.
With AI like this helping understand the targets, maybe that process could shrink down to months, maybe even weeks.
Wow. So for listeners, the big picture here is this could totally revolutionize how we find cures for diseases.
It could have a profound impact on human health, yeah. Hassabis even floats the, incredibly ambitious idea of maybe one day curing all diseases with AI's help.
Curing all diseases? It sounds like science fiction, but maybe. Maybe it's becoming plausible.
The potential is certainly there.
And he takes it even further, doesn't he, with this idea of radical abundance.
Yeah, this longer-term vision where AI helps us overcome scarcity, eliminating shortages of resources, energy, maybe even creative solutions.
That's a huge potential upside. But Hassabis also talks about the risks, doesn't he? He has concerns.
He definitely does. He's quite upfront about the potential downsides. He mainly highlights two big worries.
Okay, what are they?
First, the obvious one, misuse. Bad actors using powerful AI for harmful purposes.
Right. That's a constant concern with powerful tech.
And second, and maybe even more complex, is the control problem, or the alignment problem, as it's often called.
Alignment, meaning
Meaning, how do we make sure that these increasingly capable, maybe even autonomous AI systems stay aligned with human values and goals? How do we keep control as they get smarter, potentially much smarter than us?
Yeah, that seems critical, especially if we're heading towards AGI. And he mentioned the worry about the race for AI dominance, right? That countries or companies might cut corners on safety.
Exactly. That intense competition could create pressure to move fast, maybe too fast, and not be as careful or responsible as we should be.
So safety gets sacrificed for speed.
That's the fear. And that's why he really emphasizes the need for international cooperation, a global conversation about this, because AI's impact is going to be global. Everyone needs a say.
Makes sense. What about teaching AI morality? Ethics. Is that even possible?
Hassabis seems to think it is, or at least that we have to try. He kind of compares it to raising a child.
No.
You don't just program a child with rules, right? You demonstrate values, you teach them, you provide guidance, set boundaries, what he calls guardrails. He thinks a similar approach might work for AI.
Teaching by example with safeguards. Interesting. So bottom line, Google DeepMind is pushing hard towards AGI, AI that's basically indistinguishable from us intellectually.
That's the race they're in, yes.
And it brings up those big questions like the one Hassabis posed about the Nobel Prize book.
Yeah.
When does a machine sign it? And do humans sign it after that?
It's a powerful thought experiment, isn't it? It really makes you think about what signifies achievement when machines reach that level.
So what does Hassabis see as the next steps?
He sees us developing truly amazing AI tools first. Tools that will just enhance pretty much everything humans do.
Augmenting us.
Right. But then the arrival of actual AGI, he believes that will fundamentally change how we do almost everything.
A totally new paradigm. And as he suggests, maybe we need new philosophers, new thinkers, just to grapple with what all this means in the next, 5 or 10 years.
It certainly feels like we're entering territory that needs deep thought. So maybe to kind of summarize the key takeaways here.
Yeah, let's do that.
Okay, so AI progress, especially led by people like Hassabis at DeepMind, is happening incredibly fast, exponentially fast. We're moving towards systems with human-like intelligence, maybe even beyond.
Right.
We've seen glimpses AI that can perceive the world, reason, create, even show surprising emergent behaviors.
Like Astra.
Exactly. And this holds just immense potential, right? For science, for health, for society, curing diseases, maybe even abundance.
Huge potential.
But it also comes with really significant risks and ethical questions. Misuse, control, alignment. These need serious, careful, and probably global attention.
Absolutely. Okay, so here's a final thought then, something to chew on. If AI really could bring about radical abundance, maybe help cure diseases, what needs to change in our societies, in our own thinking, to actually handle that? How do we best use these amazing tools while managing those risks Hassabis talked about? And what does human endeavor even look like when our tools become that capable?